In the highlands of West Africa, there is a crop that defies every convention of industrialized agriculture. It possesses the very pinnacle of nutrition, a complete protein profile containing every essential amino acid required for human survival. In soils where other plants would wither, it generates its own fertilizer. It endures through droughts that decimate peanut harvests and parch fields of corn. It accomplishes all of this with no pesticides, no irrigation, and not one single commercial input. For more than a millennium, this plant formed the nutritional bedrock of West African societies. Colonial agricultural agencies meticulously documented it. They conducted studies on it. They confirmed its advantages in their own official reports. And then, they systematically concealed it. It was officially reclassified, diminished to the status of a minor crop for local consumption. In its place, they promoted peanuts and cotton for the European export market. An entire global agricultural framework was constructed around crops that demand the very thing this bean does not: complete dependency. Today, international development agencies allocate billions to fund soybean initiatives which require enormous packages of chemical inputs, while simultaneously labeling this plant as neglected and underutilized. But this was not a case of neglect. Its obscurity was a deliberate act of policy. This is the chronicle of the Bambara groundnut, the nitrogen-fixing powerhouse that colonial systems attempted to erase from history. The perfect protein that was kept alive by generations of women farmers, and the architecture of dependency that guarantees you will never even learn its name. Welcome to the Chanel. Our investigation begins long before the arrival of colonial administrators with their clipboards and production quotas. In the high-altitude regions of Mali, Burkina Faso, and Nigeria, farmers had been cultivating this plant for 1,000 years. The proof is not merely in the earth. It is embedded in the language itself. The bean derives its name from the Bambara people of Mali. In the study of agriculture, when a crop bears the name of an entire people, it is not simply a secondary food source. It is the very foundation of their civilization. From Ghana to Zimbabwe, communities wove it into sophisticated polyculture systems. Women farmers would plant it in the spaces between rows of millet and sorghum. They required no laboratory analysis to understand the synergy. They witnessed firsthand how the cereal grains grew taller when planted alongside the beans. They observed how the low-lying vines provided shade for the soil, conserving precious moisture through the recess, long and punishing dry seasons. They learned to process it into a flour that remained viable for 3 years without any need for refrigeration or chemical preservatives. In a territory shaped by the Harmattan winds and the constant threat of seasonal famine, this was not simply a meal. This was a technology for survival. The most profound technology, however, resided within the bean itself. Modern analysis confirms nutritional characteristics that are nearly unparalleled. While most legumes are nutritious, they remain incomplete. Lacking certain essential amino acids, the Bambara groundnut has a protein content ranging from 16 to 25%, which is on par with soybeans. But unlike soybeans, Bambara provides a complete protein. To grasp the significance of this, we must examine the biochemistry of malnutrition. Cereal crops like maize and millet are rich in energy, but they are critically deficient in lysine. A person can live on a diet of grain alone and still suffer from starvation on a full stomach, as their body lacks the building blocks to create muscle or repair tissue. The Bambara groundnut closes this nutritional deficiency. It contains almost twice the lysine of cowpeas and chickpeas. It has twice the amount of tryptophan. It possesses 7 times the methionine found in other common legumes. When traditional agriculturalists combined Bambara with millet, they formulated a nutritional profile that rivals the quality of animal protein. The World Health Organization performed a comparison of Bambara's amino acid composition against its own ideal standard for human dietary needs. Bambara did not merely satisfy that standard. In numerous categories, it surpassed it. But the truly remarkable fact is this: this bean also manufactures its own nitrogen. It deposits between 40 and 80 kilograms per hectare directly into the topsoil. Farmers who practice intercropping with Bambara witness their grain yields climb by 20 to 30%, all without buying a single sack of commercial fertilizer. So, the question is, if this plant delivers complete protein, produces its own nitrogen, and serves as an insurance policy against famine, why does it not form the bedrock of our global food security strategy? The answer lies in a decision made in the 1920s. The British and French colonial governments were not operating in Africa to secure local nutrition. Their objective was the extraction of raw materials for European industries. They had a demand for oil to manufacture soap. They had a demand for fat to produce margarine. They required commodities that could be subjected to taxes, loaded onto ships, and sent for processing in the factories of Liverpool and Marseille. When they assessed the Bambara groundnut, they identified a fundamental problem. African people consumed it. It was a crop for subsistence. It remained within the village. It nourished the family. It produced zero tax revenue for the empire and zero raw material for the industrial machine, so their attention turned to the peanut. Peanuts demanded greater amounts of water. They had a higher vulnerability to disease. But peanuts yielded an oil that was perfectly suited for export. The French colonial authority in Senegal proceeded to construct an entire national economy centered on the peanut. Rail lines were constructed to the coast with the exclusive aim of transporting peanuts. Funding was allocated for research facilities to maximize peanut yields. Free seeds were handed out, not as an act of charity for farmers, but as a deliberate strategy to ensnare them in an export-driven economy. And when France officially outlawed slavery in 1833, creating a labor shortage, the peanut industry devised a horrific workaround. Human trafficking caravans from the continent's interior continued to operate, but instead of being shipped across the Atlantic, these enslaved individuals were purchased by colonial settlers to labor on the peanut plantations. French administrators corresponded with their government about this delicate question of captives, arguing that cutting off this supply of forced labor would collapse the entire agricultural system. They made a clear choice. The peanut economy was more important than human liberty. By the 1940s, West Africa had witnessed millions of its acres transformed into vast monocultures of peanuts. This created a devastating paradox. Territories that were exporting thousands of tons of agricultural products began experiencing widespread protein malnutrition. Colonial-era reports confirm this reality. These same reports noted that the Bambara groundnut possessed superior resistance to drought. They observed that it thrived in the sandy, depleted soils where peanut crops would fail. They even conceded that its nutritional value was greater. And what was the outcome of this analysis? The file was marked, not recommended for commercial development. They deliberately backed the commodity that fueled their factories, not the food that nourished the local population. But this campaign of suppression did not conclude with the end of colonialism. It simply rebranded itself. The 1960s saw the arrival of the Green Revolution, which came with a grand, new vision, the modernization of agriculture. Yet, this modernization was merely a front for a very particular corporate model. It was a model based on high-yield, hybrid seeds, requiring repurchase each year. It was a model dependent on synthetic fertilizers and chemical pesticides. In this new industrial framework, the Bambara groundnut was an inconvenient truth. The plant constitutes a profound threat to the entire industrial, agricultural system. For one simple reason: it solves critical problems without requiring a transaction. Let us examine the ledger. First, there is the nitrogen threat. The market for global nitrogen fertilizer is valued at over $60 billion annually. Corporations like Yara and Mosaic have built their business on the perpetual need for farmers to purchase nitrogen. The Bambara groundnut, however, produces its own nitrogen, completely free of charge. A farmer who cultivates Bambara has no need to buy their product. Then, there is the patent threat. Bambara is an ancient, open-pollinated plant. It exists in the public trust. It cannot be patented. Seed monopolies like Bayer have constructed empires upon proprietary varieties that farmers are legally obligated to buy again every single year. Seeds from a Bambara harvest, however, can be replanted with perfect results. This means no recurring revenue stream and no corporate control. Finally, we have the chemical threat. The worldwide pesticide market exceeds $70 billion a year. But Bambara co-evolved within this very environment. It possesses an innate resistance to the regional pests and diseases that can wipe out non-native crops, such as imported soybeans. Every single characteristic that makes Bambara an asset to a small-scale farmer renders it an economic liability to a multinational corporation. Consequently, for half a century, research funding was directed elsewhere. Agricultural institutes poured tens of millions of dollars into adapting soybeans for Africa, a crop ill-suited to the climate and demanding costly chemical inputs. During this same period, Bambara was given practically no financial support. In 50 years, fewer than 10 improved varieties of Bambara were developed, while soybeans saw the release of more than 100. Development organizations labeled the crop neglected, but the people never neglected it. As the World Bank underwrote loans for fertilizers and export-focused agriculture, it was the women of West Africa who ensured these seeds would survive. From Burkina Faso to Mali to the northern regions of Ghana, female farmers steadfastly refused to give up on this plant. They grasped a truth that the scientists had overlooked. A high yield is meaningless if the crop perishes when the rains fail. And today, the rains are failing. Climate change is revealing the sheer folly of this industrial approach. Across the entire Sahel region, rainfall patterns are becoming dangerously unpredictable. The crops dependent on external inputs, the maize, the soy, the peanuts, are collapsing. They were engineered for a climatic stability that is now a thing of the past. The Bambara groundnut, in contrast, was engineered for instability. It can yield a harvest on as little as 300 millimeters of rain, whereas peanuts demand 500, and soybeans require 600. Bambara can withstand temperatures as high as 35 degrees Celsius. It produces food in soils so impoverished that other legumes simply die. Now, all at once, the global scientific establishment is in a panic. Universities are rushing to publish research on climate-smart crops. The Food and Agriculture Organization is hosting summits on the foods of the future. They are desperately searching for the very qualities that Bambara has always offered. But pay attention to what remains absent. You see no massive government initiatives to distribute Bambara seeds. There are no financial incentives for farmers to adopt it. The reason is simple: the debt trap is a feature, not a bug. Contemporary development aid is frequently structured around loans. African governments are encouraged to borrow money to subsidize the purchase of fertilizers and patented seeds from Western-based corporations. These loans are designed to create dependency. This debt is designed to create markets. This dependency is designed to create a permanent stream of revenue. A plant that requires no purchased inputs generates no debt, and a plant that generates no debt provides no leverage. The Bambara groundnut offers an escape from that system. This system represents the very definition of food sovereignty. It is the mechanism by which a community can generate complete protein, regenerate its own soil, and preserve food for 3 years without ever signing a contract with buyer, without accepting a loan from the MECAND, World Bank, and without depending on nitrogen purchased from Yara. This is its perceived danger. This is the reason it was concealed. The colonial administrators understood this fact. The modern development agencies understand it as well. And yet, the women farmers of West Africa never lost this knowledge. What we are witnessing today is a quiet, powerful revival. You can now purchase Bambara flour in Lagos markets. You can find roasted Bambara snacks for sale in Accra. This wisdom outlasted the suppression. Each farmer who puts a Bambara seed into the ground offers proof that the industrial food model is not the only path forward. They demonstrate that you do not have to poison the earth to nourish a community. They establish that the most sophisticated agricultural technology is not a patented genetic modification engineered in a laboratory. It is, in fact, a seed that has evolved over 1,000 years to thrive in the precise conditions we confront today. The legume that upheld entire civilizations continues its work. It continues to fix nitrogen in the soil. It continues to combat malnutrition. And it continues to wait for the rest of us to comprehend that the answer to hunger is not something sold in a bag. It is something that grows freely from the earth. If this vault has revealed a new truth to you, subscribe to the channel and activate notifications. Every single like and every share helps us safeguard the knowledge that they have spent decades attempting to eradicate. Some plants are simply too nourishing for corporate control. Some seeds are too priceless to be patented. And some wisdom is too profound to be repressed indefinitely. The next vault is opening soon.